Welcome back. Last time we were talking about trigonometry, the study of triangles. You'll remember our example with the 3, 4, 5 right triangle and defining the three elementary functions of trigonometry: sine, cosine, and tangent. Well, today we introduce another important concept. If I were to draw a circle from the point of this triangle, so notice that without a compass, I was able to draw a circle by using a loop of rope, because it maintains a constant radius from the center. Now, if I were to chop this into quadrants from the same point of the triangle, there, a vertical axis and a horizontal axis. Instead of adjacent, opposite, and hypotenuse, I'm going to call this x and this y, and this r for radius. If I set this r equal to 1, we have what is called the unit circle. Unit meaning 1. We can define the same functions. This time, sine, opposite over hypotenuse, y over r. Since r is 1, it's simply y. Cosine of theta is equal to adjacent over hypotenuse. X over 1 is x. And lastly, tangent of theta, opposite over adjacent, is going to be y over x. That is the unit circle. Some important points on the unit circle, starting with 0. When theta is equal to 0, when theta is equal to 90 degrees there, 180 degrees, 270 degrees, and then back here we'd be at 360 degrees. Those are important. There are some intermediate points here at 45 degrees, over here at 135 degrees. Here we're at 225 degrees. Here we're at 315 degrees. So I bisected 90 degrees, chop it in two. Every 45 degrees, I can put another point. Then every 30 degrees, that's another 30, 45, 60 degrees. We can go to 90 plus 30 is 120 degrees, plus another 30 puts us at 150 degrees. 180, 210, plus 30 is 240 degrees, plus 30 is going to put us at 300 degrees, another 30 is 330 degrees. Okay, so these are some important points. If you ever look at a unit circle, you will see them. Now, why are they important? They're important because we know the exact value. For example, here, if theta is equal to 0, okay, what happens to y? Y comes down to 0. Sine of theta is equal to 0. Meanwhile, cosine, that's the x value. What happens there? Well, it becomes equal to the radius of the circle, which we've defined as 1. So cosine of 0 degrees is 1. If we're all the way up at 90 degrees, well, then the opposite happens. The x-coordinate has gone to 0. So 90 degrees, we're at 0. So cosine of 90 degrees is 0. Sine is y. Well, that has become equal to the radius, which is 1. Right? What happens when we're over here, 180 degrees? Well, cosine, it's now equal to the radius again, but now it's in the negative x direction. So this is cosine of 180 degrees is negative 1. And sine is 0. At 270 degrees, well, y is equal to the radius, but that's in the negative y direction, so sine is negative 1, cosine is 0. So we can put coordinate pairs to indicate sine and cosine as a function of theta. All right, now where do we get the 45 degrees and 30 degrees? Well, that brings us back to geometry. Remember, if I have a square means all the side lengths are equal and they're all right angles. Well, we've defined a right angle to be 90 degrees. If I bisect that, okay, that means I've cut it in half. 45 degrees on this side, 45 degrees on this side. If my side length is equal to 1, okay, that means all the sides are equal to 1. By Pythagorean theorem, 1 squared plus 1 squared is 2. So the hypotenuse is going to be the square root of 2. Okay? So what is sine? Opposite over hypotenuse. So sine of 45 is 1 over square root of 2. Same with cosine, adjacent over hypotenuse, 1 over square root of 2. Sometimes you'll hear that we need to rationalize the denominator. So I'm going to multiply both the top and bottom by the square root of 2. 1 times square root of 2 is square root of 2. Root 2 times root 2 is 2. So 45 degrees, I'm going to have root 2 over 2, root 2 over 2 for sine and cosine. Same thing over here, except now cosine is going to be negative root 2 over 2, because we're in the negative x, but positive y, so sine is positive root 2 over 2. First quadrant, second quadrant, third quadrant, we are at negative root 2 over 2, and now we're negative y, so negative root 2 over 2. 315, we're quadrant 4. 1, 2, 3, 4. Okay, we're back in the positive x, so cosine is root 2 over 2. Y is still negative, so that sine is going to be negative root 2 over 2. By the way, if you punch this in your calculator, it's going to be approximately equal to 0.707 ... It's an irrational number, so the decimals continue unrepeated for infinity. All right, so 45 degrees comes from a square. Where do you think 30 degrees comes from? Well, if you guessed a triangle, you're correct. If you guessed an equilateral triangle, you are very correct. So, let's say this is side length 1, 1 to the middle. So that makes the total side length 2. 2. By Pythagorean theorem, 2 squared is 4 minus 1 squared is 3. So the altitude here is going to be the square root of 3. There's 180 degrees in a triangle. Divide that by 3 and we get 60 degrees here, 60 degrees here, and 60 degrees for the whole angle here. So this here is 60 degrees. All right. So then that would mean this here is 30 degrees. We'll come back to that. Let's do sine of 30 degrees. So this is my theta in this case. Opposite over hypotenuse, 1 over 2. Now notice that is the same as the cosine of 60 degrees. So 60 degrees would put theta here, adjacent over hypotenuse. That's a good pattern to note. In general, we're going to say sine of theta is equal to cosine of 90 minus theta, 90 degrees minus theta. Okay, we'll come back to this when we discuss trig identities. How about the sine of 60 degrees? Well, 60 degrees puts my theta here, opposite over hypotenuse. Opposite is root 3, hypotenuse is 2. Again, sine of 60 is the same as cosine of 30. Cosine is adjacent, so 30 puts theta here. Adjacent is root 3 over hypotenuse is 2. So, important patterns to note. If you punched, well, 1/2 is obviously 0.5. Root 3 over 2 is approximately 0.866 ... Just to give you an idea. I should note that any sine or cosine value is going to be bounded between -1 and +1. +1, -1. Okay? Sine and cosine cannot go outside of those bounds. I can fill in the unit circle. 30 degrees, what did I say? Cosine is root 3 over 2. And sine is 1/2. And that looks about right. If we're here, the cosine is 0.866. The sine, the height is 0.5. That looks about right visually. And then it's just the opposite here, right? 1/2 and root 3 over 2. Then we start changing signs. So cosine is negative in the second quadrant, but sine remains positive. So negative root 3 over 2, 1/2. Okay, now negative root 3 over 2, negative. Third quadrant, both sine and cosine are negative. And then, so notice this. If I drop down vertically, right, root 3 over 2, and 1/2, 1/2. So those match up. So then here at 240, it should match up with this, other than a sign change, negative 1/2. So positive root 3 over 2 changes to negative root 3 over 2. 300 degrees, okay, drop down. Fourth quadrant, cosine is positive. Sine is now negative. So negative root 3 over 2. And lastly, 330. So drop that down. Cosine is positive. Sine is negative. Okay, that's a unit circle. You can find these in just about any textbook on trigonometry, or even in the chapter of trig in some pre-calculus textbooks. Unit circle, very common. I suggest you become very familiar with this. Know the values, know where they are. Better yet, know where they come from and how to find them. So thanks for watching. Next lesson, we're going to talk more about trigonometries. That concludes this lesson. To see more videos like this one, consider subscribing to my channel. That way, you will receive notifications when I post new lessons. Also, be sure to utilize the comment section below for any questions or suggestions you may have. If you enjoyed this video and learned something new, please click that like button. As always, thank you for watching. I will see you next time.